All right, so this one's kind of practical. We're gonna be optimizing, or we're gonna be working with airport routes. So we're gonna be given an
Okay.
origin airport and a destination airport and a list of flights. You just need
All
to
right.
tell me if it's possible, or did you switch language?
I switched, I think. Oh, here it is. Yeah, it's here.
Yeah. So
Okay.
we're gonna be given an origin airport and a destination airport and a list of flights. We pretty much just need to figure out if we can actually ship a package from the origin airport to the destination airport, given the list of flights.
Uh-huh. Okay, so the flights are like start, end, and then like the start thing. Okay, I
It's
see.
like badly formatted. Wait, let me see. One sec. Let me give you a bit. It's gonna.
Is this like a Google one as well, or did you come up with this yourself?
Yeah, this is a Google one.
Okay. Okay, so package starts at the original. It can only board a flight. It's greater or equal to. Task is determined it's possible to transfer the package from the origin to the destination.
Yeah.
Okay. So from NYC to SFO. Okay, I see. Okay, so all these flights have a departure and arrival time. Okay. Yeah, so definitely without like if you got rid of this, then this would just be like a BFS from the start one. But with the departure and arrival, it becomes a little bit trickier.
Mm-hmm.
I'm trying to see if we can still do a BFS. Like maybe for all these different flights, they're kind of like unique, and we treat them as separate. Let's see. So NYC, LAX. Yeah, like in this case, like, well, actually, let me just figure out. Well, let's me look at the second example. So NYC SFO. Okay, I see. Mm. Or would it be like, would it be BFS or would it be like Dijkstra? Like literally just Dijkstras from the start, and then you get to cities as fast as you can. Yeah, you get to cities as fast as you can, and then once you're at a city, you try to go. Yeah, I feel like that would make more sense. So like Dijkstras from the starting, but let me just. Okay. Let me just figure out here. Package arrives at LAX. Okay, okay. So I get this, and then as far as like uh questions or something, I don't think there's anything here. So yeah, I guess what's the format of our inputs here? Like some kind of thing that's like string string int int or something? Like some kind of object with those things,
Where?
I guess. Like what's the format of our inputs? Is it just going to be
It's
like
gonna be a list like this. So it's maybe a string,
uh-huh.
and then a string, and then two integers.
Okay.
So maybe the first element is a tuple that shows the source to destination.
Okay. Can I just say like the first or yeah, can I just like make a like some object for that or something so I can get it? So I'll just say like string start, string end, int departure, int arrival or something. Just so I don't have to do like string parsing
Sure.
because that's
Yeah.
not really okay. Yeah, so I'm thinking we do like Dijkstra's, and then what do we need to do for Dijkstra? So yeah, it's not like Dijkstra's, I guess. Let's see if this even works. So we start at the origin at time 0. And then as far as like the departure and arrival. So basically as long as we can make the departure or something like that on time, then we are good. But yeah, if there's an edge, if we can't, then I don't think we even add it to the graph. So like if we go from like NYC to LAX, and then we go from LAX to SFO, like we can't even add that edge, right? Essentially, because like we're at LAX at 4 and we need to depart at 3. So I don't know how to make it like optimal. Yeah, I guess can I ask like, are there like loops? Probably. Like you can go from like NYC to LAX and then LAX to NYC or something. Like that's obviously gonna be allowed.
Yeah, there can be loops, and you could possibly get to LAX faster in different routes.
Yeah. So I wonder if we can like. Hmm. Like if we start at like we start our starting destination and we just like traverse those edges. So we have to know for sure like there's a path to the city we have to get to. But then we also have to figure out like are we able to take all those edges? And probably the way to figure that out is like when we get to a city, we have to write down like what time we got there, and if we get there later, then we can ignore those. So we can say like if we get to a city, we have to write down what time we got there. And if we get there later, then we can ignore that, right? So if we know, which is basically like Dijkstra, is like if we know we got to like LAX at time 3, we don't need to get there again at like time 10 because it would just strictly be worse. So we can have some kind of like map of like city and like earliest arrival or something.
Yep.
And then we need the edges as well. So as
Like,
far as the edges, can we
how does
also
that?
assume that what? Sorry.
Well, I was just saying, like, how does it affect? Like, pretend we can get to a city faster, like the fastest possible. How does that affect?
Well, if we got to a city like at time 2 and we get there again at like time 10, we can just like skip over that because like
Mm.
it's never going to be better, right?
Mm.
So it'll be like for optimization of like the algorithm, I guess.
Yep.
Does that make sense? So we're basically just going to be like, kind of like the shortest path thing. Like if we get to a city, if we get to a place twice and the second time is slower, then we can ignore it.
Yeah. Like,
Yeah.
how does that
So,
affect the options if we get there later?
oh, sorry. Yeah. So if we get there earlier, we can, like, we can depart on time, right? So we get to a city and it has like things it can go to. The earlier we get there, ideally, is better, right? Like if we get ideally wherever we're at time 0, and then all the edges we can make. Like if we get to LAX at 2, for the second example, we can make the flight, but if we get there at like 5, we can't.
Mm.
So the optimal is just get there like as early as you can.
Mm.
Um, yeah, and then the part I need to figure out is like if we're at and for what it's worth, yeah, I think this is probably like not a 20-minute question. Maybe it is. I don't know. But if we're at some airport,
This is a
and
30-minute one, probably.
it has flights that we missed, then we like skip those, right? So for example, if we're at LAX at 3, we can't take this flight. So I think it's some kind of like Dijkstra's, and then whenever you get to an airport, you check like when did I get there, and then what are all the flights I can take, and you add those to the graph. Now, when you add those to the graph, can we also assume that like if there are, or yeah, I guess are there duplicate edges? Like if there another LAX SFO?
No, let's keep it simple where it's just one.
Okay,
Or, I mean, there could be.
there could
Will
be,
that
right?
affect?
But
Will that affect the solution that you're mentioning?
yes, because like if there was an LAX SFO departure at like 10, can we assume that like for the same flight, the length of the flight is the same? So like if it's like 3 to 5, it'll be 3 to 5 again. I don't know if that'll matter, but just probably good to know. It might matter. Does that make sense? Like, so if we ever have an LAX SFO flight, it'll always be the same duration. It just might have like different departure times.
Mm. Sure.
Okay, but yeah, it definitely would matter, right? Because if we have another edge, LAX, like for the second one, if we have the LAX SFO departure like 6, arrival 8, then we can make it. So yeah, okay. So what do we need to write down like for the airport? Basically, we need to write down.
Well, actually, no, no. Let's not assume that. let's assume that we won't have two flights at the same time, like no two NYC to LAX. But if they
Okay.
depart at different times, it could be slightly different because in real life, like
Okay,
they could
got it.
actually.
Okay. Okay. So basically what I'm trying to figure out is like what info to keep here. Like we have some airport that we're at that we add to the like let's say well actually no, yeah, I don't think it would matter. I think yeah, it wouldn't matter because basically we'd be at like NYC and we check, oh, we're at time 0, there's a path to LAX. Um and then we can get to LAX at 4. And if we were at like time like 0 and the departure from NYC to LAX was like 6 to 10, then we can just uh then we can just take that instead. So we can basically say like, okay, we're at time 0 at NYC. So then if the NYC to LAX is 6 to 10, we'd be at LAX at 10. So we can just calculate like, did we make the departure? And then the time we care about for the other one is like, so we care about airport and arrival time. And I can assume that like if we depart at 0 and arrive at 4, we can depart at 4 and arrive at 5. We can depart, or we can like depart immediately after arrival. Like, does that work?
Yeah.
Okay.
Yeah. If we arrive at 4, and then it departs at 4, we
Departure is
can
at
make that
4.
flight.
Yeah. So I think the plan is basically make a map of like all the edges. Um, yeah, make a map of all the edges. So map like city, and like edges here. And then start at city 0 at time 0 and use a heap. And then just, I mean, I don't even know if you need a heap, but for now we'll use a heap. Maybe I'll think about it later. And use a heap and just see if we can get to the end. And yeah, whenever we visit a city, we'll just mark like when's the earliest we could have been there. And if we get there later, then we can ignore those because that'll never be better. So I feel like that will work. And then we just check like if we ever got to the one we care about, if we ever get to the end, then we made it, I guess. Yeah. So does that sort of make sense? I might have to modify some stuff later on, but essentially that's my plan is like the instead of a visited set, we'll have this city and earliest arrival, kind of like optimized Dijkstra's, like location and like earliest time to reach.
Yeah.
And then we'll have the edges map, and then we'll just try to get there. I might
Yeah.
have to modify a little bit, but I think that should work. So let me make some things just to make it easier because it's Java. So I'll make like this uh like edge or something. And I'll just say the edge has like a string from or like start, string end, int, departure time, and then like int arrival time.
Like we're not gonna be running anything, so you could just assume that yeah we have.
Well, yeah, I'll just have it in this format, and then I
Okay.
won't be. Oh, yeah, that's right. I won't be running anything. Yeah, okay. And then I could just dry run some solutions. Okay, so we
Yeah.
have this edge. Um, in our heap, we're gonna have a city and an arrival time. Yeah, so we can have that as well. Like city arrival. That'll just be like string city int arrival time. Okay, I think maybe that's all we need. Yeah, I guess I won't have like a main, or I will have a main, but I won't like use it. And then I'll have a thing here, so it'll be like static. It's just a boolean, and then departure. Yeah, we can call this like can ship package or something. So it'll take a list of edges. What else? Is that it? I think. Oh yeah, we have the origin airport as well, right? So we have a list of edges, and then we have the origin airport.
Yeah.
Okay.
Yep. And edges are
Cool.
in the format you mentioned.
Yeah. So they'll be in this format of edge. So start end. This is basically how you can just make a tuple in Java really quickly that I
Yep.
found out.
Makes sense.
Okay.
Sick.
Yeah. So for each one of these edges, we need to add these things. And so there needs to be a slightly formatted different. So instead of edge, it needs to be like a graph edge. And this will just be like string and departure time, and arrival time. Because like if you're going from one city, you're going, well, actually, I think I can use the same thing. It's fine. It'll just be redundant. Okay, so we need to make a graph. So we need to make map string to edge graph, and this is directed hash map. Okay, so for edge and edges, so graph compute if absent, and this is like getter default. So we need to get the edge start. We need to make a new array list. And then we need to add the edge here. So edge. Okay, so now we have this graph. Yeah. Oh, wait. Cannot infer. Oh, it's because I screwed it up. There we go. It's a list. Okay. So then we need to have a heap. And this needs to be in the format of this like city arrival thing.
Yep.
And we need to sort it by times. So this will be like a B. A. This over. Let's see. A. What did I call it? City or no, arrival time. B arrival time. Okay, so we have the heap. We need to add to the heap our initial city. So new city arrival origin at time 0. And we need to mark it visited as well. So, we need to have the set visited.
Yo, Ryan,
or like
what's
the
up?
map visited that I said. So it'll be a string. And then, yeah, basically this thing right here, the city earliest arrival. So earliest arrival will just be an integer. And this one can be called like earliest arrival.
Yep.
Okay. Then we know we can get here at 0. So earliest arrival, but origin at 0. All right. So essentially now, while we have this heap, we need to go to all the edges, and then add them in if we need to. We have in our heap, we have like the city arrival when we get there. So okay, so let's try this. So while
do a cache here.
Empty. Yeah, this would actually be cool if it was a LeetCode problem and I could like run it, but I'll do that later.
Yeah.
I feel like, but that's okay. So honestly, this is like a pretty good problem. So okay, so while heap is not empty, we're gonna pop the what's in our heap? City. So like current city or something. Equals heap full. Okay, so if I guess in this thing we're supposed to have like a string destination, right? That was like the last part that I didn't mention in the input. So we have this like can ship package origin destination. Okay, so if this city is, and let's get this. So this will be like actually city or cur arrival or something. So this cur city, cur arrival city, and then int time equals cur arrival.
Yeah, this is a pretty interesting real world problem. Like ship an Amazon package. Find a flight.
I feel like this would be this kind of like Amazon thing. I know they ask kind of like Amazon specific, and they really word it like in this weird way where it's like we're shipping stuff from, but it ends up being like a LeetCode problem. They just have like all this like backstory.
Yeah, exactly.
Okay, so basically, if the current city is the destination, then we can return true. Okay, and then now we need to go through all of the edges from this city. So far edge graph get Or it might not be in here. So get this cursed city, and the default value can just be nothing. Okay, so we need to check if this edge is able to be taken. So we can say like int depart, I guess. Yeah, depart. Sure. Time. Edge. Departure time. Arrival time. Edge. Arrival time. And finally, string destination. Or I guess not destination. Location or something. Edge. Where is it? What did I call it? Start, end, end. Okay, so if the departure time is less than our current time, then we're just not able to make this flight and we can just skip.
Yeah.
Then we can also calculate like, so yeah, I guess basically then if we are able to make the flight, we're always making it at arrival time, right? There's nothing to calculate. Like we might have to wait for the flight, but we're always going to be there at the arrival time. So
Yeah.
if so we need to check if arrival time is greater than earliest arrival at location, and our default can just be like max value or something, because then we know it for sure won't be. We can skip as well because this edge is no good. Okay, now we know the edge is good, so we're going to update the earliest arrival. Location, arrival time. And we're going to add it to the heap. And so city arrival, location arrival time. Oh, and then we just return like a false at the end, and I think that's it. But let me just check, and we can dry run these like examples. So we have a graph. We have the earliest arrival heap. We have a min heap based on arrival time.
Yeah.
Yeah. So we put origin at 0 because we're there right away. So we get the city, we get the time. We check if we're there. If we are, we're true. For an edge, we get the departure time, the arrival time, location. If the departure time is less than time, we miss the flight.
Yeah.
If we already have the city in our heap at an earlier time, we never want to take that.
Sure.
Then if not, we update that, and then we add it into the heap. Yeah, I feel like that works. We can try it on these like examples. We can dry run if that works on like example 1 and 2. Is that good? You want me to just dry run on like the ones you have?
Yeah.
Okay.
I think it works though. The solution makes sense. Unless it like
Yeah.
some of these ones are so hard to dry run. Like you're working
I mean, the
with
nice thing is yours has like 3 edges, so I think it'll be not too bad.
Yeah, let's work through the example then.
Okay. Let me actually just like I kind of know what's happening in the code, so I'm probably not just gonna go like line by line. I'm just gonna walk through what is gonna happen.
Nice.
So
I actually got this one in 20.
in 20, that's
Yeah.
pretty nuts to be honest. Oh wait, I need a thing. I think with these ones, like you kind of aren't sure where you're gonna end up. Like you're like, oh, you might start writing stuff and then it might be incorrect.
Mhm.
Okay, so anyway, so we have these flights. So NYC. Yeah, I guess we have these flights. This is our graph. This flights is our graph. So we start basically at NYC at time 0. And so that's our heap. Then we pop from NYC, and our visited set is basically this, like NYC at time 0. We pop from NYC. We check where can NYC go to. We can go to LAX. So then we update our like visited thing to we can get to LAX at time 4.
Yeah.
And our heap will be just LAX. Then we pop to LAX, and then we can go to SFO. So we can get to SFO at 5 or 7. And then we pop SFO from our heap, and that's destination, so that works. Yeah, I mean, this one is like almost too small to really test anything, but it's
Yeah.
fine. So this first one works. So for the second one, so we have NYC at times 0 again, and this is our heap. So just NYC heap. And then we check the edges. So NYC can go to LAX at time 4. We haven't been to LAX yet, so we update LAX 4. Then we add LAX to the heap at time 4.
Yeah.
Then we pop LAX and we see where can LAX go. We can go to SFO, but we missed a flight, so we can't go anywhere. And then our heap is empty, and then we just return false. So yeah, I think it's good.
Yeah.
And in Java too, which is like the hard part. I had to
Yeah.
make all these freaking things.
Does this run?
So, probably not.
It's all good. Cool. How's that question? Like any comments of where your mind went that shouldn't have, or you just got there? Anyway?
I'm still not 100% sure we need a heap, like, because you just need to get there anytime. There might be something better. There might be some BFS thing, but I think with a heap, basically I went with a heap because I was like, can we do, like, my mind originally was like, all right, if there were no times at all, I would just do a BFS and just check, like, is there a path? Maybe that's still a thing, honestly. Like, just do a BFS and then skip the edges that you can't go to. Like, maybe that still works in some weird way. I feel like it might, and it might be better, but I would have to, like, double check.
Yeah.
But I was just more confident in this. And that's also, like, the interview thing is, like, you might have 2 solutions and one might be better, but you're, like, really confident in one. And you're like, I don't want to do the one that might not work, so let me just go with the one that, like, I'm pretty confident in, even though it might be a little bit worse.
Yeah. I mean,
So,
what I'll tell you is, because I looked at this question already, is that
Uh-huh.
yeah, Dijkstra's is the most optimal because yeah, pretty much we just need to guarantee that we can get to we need to get to the airports in the earliest time because it leaves us the most options.
right,
So
yeah.
if you just did like a DFS or BFS, like you might explore too many solutions. Like it could lead to like really exponential blow up.
Yeah,
Like
yeah,
trying
that's
all the
possible.
different spots, like all the different ways, and then like you could maybe do a backtracking algorithm.
Like, there's some BFS solutions for some problems, and I've even coded some where people
Yeah.
were like, oh no, you have to do heap, and I was like, no, you could do a BFS. But it's kind of tricky, and you have to really know what you're doing. Otherwise, yeah, I can get into this. So it's not one I'm kind of like, if I had DP in an interview, I would probably almost never do bottom up because I'm like,
Yeah.
well, I don't care about TLE on leak code, and I can get it completely right and top down. So
Yeah.
I would just say, like, I know bottom up exists, and I know we can, like, space optimize or whatever. Let me do top down in like 5 minutes, and then we can optimize because I have a working solution.
Yeah.
So same kind of thing here. Like, maybe I'd code this, and then they're like, how can you optimize? And I might think like, okay, let me try a BFS one now that this works. And it might work, it might not 100% sure. But there's like all these nuances with BFS that most people don't know that do work, but they're not like something you don't really want to experiment in an interview and then be like, oh crap, like 20 lines in, it doesn't work.
Yeah.
So,
Makes sense.
yeah.
Pulsing
Yep.
fail.
Fail, yeah.
Oh, that's good.
Fair.
All right, man. All right. Good luck
Bro,
with
I'm
your
a
stuff.
freaking Java expert.
Yeah, you got like
weird.
I seen you get good from
Like, I feel like
your
I'm
first
better
one.
with Java. I also know all the Java internals now. And I figured out the sorted set thing isn't a Python internal, where like tree map and tree set and all this stuff is a Java internal.
Yeah.
So Java actually has more things you can use. Plus, you can build custom comparators for everything, which is like better than Python. So just more lines of code, but you can do a lot if you know how to do it.
Yeah. I remember when I
But
was
it is
studying
funny.
for my.
Sorry,
Or,
go ahead.
go ahead.
I was gonna say, so we interview people, and
Yeah.
someone even mentioned like everyone who interviewed in Java for a job failed.
Yeah.
Like, you have to really know your shit. And even for some, like, I just tell people, like, if I interview, I'm like, yeah, let me see the problem, because like some problems are going to be a disaster, and I'm not doing Java. But if it's
Yeah.
not like some nested object with like a billion types, then I can go with it.
Yeah. No, I agree. I noticed the same thing too. Like even strong candidates, they use Java and they just end up failing. I was like,
You can run out of time, yeah.
Yeah.
But I feel like I'm super fast now. Like, it's more lines of code, but like, you know, I'm locked into the Java. So yeah.
oh yeah. All right, man. Good luck.
All right,
Catch you in
cool.
the next
See
one.
ya.
Peace.